To meet the octet rule, atoms are going to make bonds with one another. They're going to interact with one another. There are 4 different types of bonds we're going to go over in this lecture, and we'll take them one at a time. First type of bond is known as an ionic bond. Ionic bonds occur between ions. So first, we need to discuss what an ion is. An ion is an atom that has either gained or lost one or some of its electrons. For instance, over here we have chlorine. Now, chlorine has an atomic number of 17, so if you count out its electrons, that means that it has 7 on its valence shell. It needs to get one more to be happy, to fulfill the octet rule, so it has a tendency to steal these electrons from other atoms and add it to itself. Now, after it's done that, it will have 8 electrons in the valence shell, so it's more stable that way, it's more happy, it's happier that way. It will also get a charge. Since that little electron had a negative charge and it added it to itself, the entire atom is going to have a negative charge. We can show this by listing the atomic symbol and putting a negative charge after it. A negative charge indicates that an atom has gained an electron. If it has a -2 charge, that would tell you that it's gained 2 electrons. Atoms can lose electrons as well. Here we have sodium. Sodium has an atomic number of 11, which means that it has 11 electrons and one sad little electron on that third shell all by itself. Now, it's much easier for sodium to ditch that little electron than to gain 7 more to meet the octet rule. So that's what it tends to do. It tends to give that electron away. It's got this annoying extra. Now, when it does that, the second shell becomes the valence, which is full with 8, and it's happy that way. Now, because electrons are negative and it gave it away, that means that it's going to have a positive charge overall. The atom will be positively charged. Another way to think of it is that this atom will have 11 protons in the nucleus that are positive, but only 10 electrons out here that are negative. So if you add that up, you get a +1 charge. We would express this by saying Na+, and that indicates that that atom has lost an electron. If it said Na+2, that would indicate that it has lost 2 electrons. These types of reactions can result in 2 different kinds of ions. Cations are atoms that have lost an electron and therefore have a positive charge. So sodium was our example of a cation in the last example. Atoms that have gained electrons we call anions, and they have a negative charge. So chlorine was an example of an anion in the last example. Now, how do you remember these 2 words? Well, here's my dumb memory trick. When I think of the word cation, I think of the Cheshire Cat. The Cheshire Cat has this really big positive smile. So, that's weird looking. So cation, positive charge. When I think of the word anion looks a lot like the word onion to me. So I think of a big old negative stinky onion. And that reminds me of the negative charge. Now, when we put anions and cations together, they can form a bond known as an ionic bond. For instance, when we put sodium and chlorine together, sodium will give its electron to chlorine. Sodium will get a positive charge, chlorine will get a negative charge, and because opposites attract, remember Paula Abdul, a bond will form between these atoms. Now notice they're not overlapping, they're just attracted to one another. So we show this with a little lightning bolt here. Not a solid line, not a dotted line, a weird little lightning bolt. Those are bonded together. Compounds that form with ionic bonds tend to form what we call salts. Salts are crystals in shape, so they make these repeating patterns that are kind of neat. And yes, table salt is sodium chloride. It's a great example of an ionically bonded compound. Ionic bonds tend to form between metals and nonmetals. So what are those? Well, these are just classifications for the different elements. And the nonmetals are these: hydrogen, and then all of these guys in orange from here over to the right of the periodic table. These are our nonmetals. The metals are the ones in gray. So now notice, in table salt, we had a metal, sodium, and a nonmetal, chlorine, making that bond. Ionic bonds tend to form between metals and nonmetals. They are most common between these guys in the first and second column over here, and in these columns over here. And the reason is that these guys have 1 or 2 extra electrons that they like to give away, and these guys have 1, 2, or 3 electrons that they would love to get. The second kind of bond we'll address is called a covalent bond. Now think about that word, co as in community, as in sharing, and valent as in valence shell. What happens in a covalent bond is that 2 atoms that need electrons will get really close together. They will overlap their valence shells. So that one's overlapping with this one here. And they will share electrons. When they're sharing an electron, that means that the electron from one atom can zoom around the nucleus of the original, or it can zoom around the nucleus of the new atom that it's interacting with. So this is a sharing bond. Now, neither atom really gains an electron, but they have access to it, and it kind of helps balance them out. Here, for instance, we have a water molecule, and it is covalently bonded. Each hydrogen needs 1 electron to be happy, and each oxygen needs 2 electrons to be happy. So this big old oxygen has cozied up with this hydrogen. It's sharing an electron with that, makes them both happy. And since it needs 2 electrons to be happy, it has to share with a second hydrogen to fulfill the octet rule. So now the electrons can fly around the valence shell of the oxygen or the hydrogens, and it stabilizes them. We consider the sharing of 1 electron pair to be 1 bond. Atoms that make covalent bonds can share different numbers of electrons. Here we see 2 atoms making a single covalent bond. These are both hydrogen atoms, and each of these atoms just needs 1 more electron to be happy. So each hydrogen has an electron, and it's going to share it with the other. That means that occasionally 2 electrons will be flying around either of the nuclei, and that helps balance them out. When they are only sharing a single electron with each other, we call that a single bond, a single covalent bond, and we represent that in the structural model with a little stick between the 2 symbols. This is hydrogen gas, or H2. Atoms can share 2 or 3 electrons with each other. If they share 2 electrons with each other, we call this a double covalent bond. And oxygen gas, O2, is a great example of that. Each oxygen atom in this molecule needs 2 electrons to be happy. So they can overlap. This one can share 2 with that one can share 2 with that one, and it helps balance them out. We call that a double bond. In the structural model, we represent that with a little equal sign between the 2 symbols. Again, this is O2 gas, or oxygen gas that we breathe. Atoms can share 3 electrons as well. We see this with nitrogen gas, or N2, and we represent that with 3 little lines. This nitrogen is sharing 3 electrons with this nitrogen, and this one's sharing 3 with this one. So we call that a triple bond. Tetra bonds or quadruple bonds are possible on paper, but we don't really see them in nature because they put too much strain on the atoms trying to share. So single, doubles, or triples are about it. Covalent bonds tend to form between non-metal atoms. So for instance, you might see hydrogen and oxygen getting together to form water, or you could see chlorine and hydrogen getting together to form methane.